Okay, so another verification proof here. I'm going to take a bit of an unorthodox approach to this one. We talked about something, hopefully, I don't know, I'm kind of recording these things back to the future, but we will at some point have talked about how we're supposed to have this expression look exactly like this. Okay? Now, what that entails could mean many things. In this case, maybe we want to try to add these two terms together. And in that process, maybe it will end up looking like just this one fraction right here. Okay? There's something a little unorthodox that we could also try in this case, and that is what I call decomposing the fraction. If you look at the left side of this equation, can't call it an equation, the left side of this proof, we have one fraction. We have a fraction, a singular fraction, that in the top, in the numerator, has two terms with a single denominator. Okay. On the right-hand side, we've got these two terms. So what I'm going to try is, like I said, decomposing the fraction. What did this fraction look like? What did this fraction look like before it came to look like this? If you think about what it might have looked like, so when there is a singular denominator with more than one term in the numerator, we can separate that into two fractions. Now, they both have to be written over that denominator. But again, the idea is, it doesn't make sense to do this all the time, but I'm trying to rewrite this whole thing to look like the right side. And since the right side has two terms, maybe I can take this one fraction and turn it into two terms. Okay? These are the two terms that I would have added together to give me this fraction. When I decompose it, it looks like this. Now, the left side, you'll notice, is all in terms of sine and cosine. The right side has neither of those. So what we're looking at right now, and this is an approach you're going to have to take a lot of times, is we've got four different trig functions written in this problem. Sine, we've got a sine function, we've got a cosine function, we've got cosecant, and we've got cotangent. That's four different trig functions. Okay, if we can, we want to eliminate some of these. And when we talk about eliminating, when we talk about removing with these verifications and with these simplifications, it's not about subtracting or dividing them out. It's about replacing them with terms that are more consistent with what we already see. What am I trying to say? If you look at the right side of this, okay, there's not much I can do with these sines and cosines, but on the right side, cosecant, what do we know about cosecant? Cosecant is the reciprocal of sine. What do we know about cotangent? Cotangent can be written as cosine over sine. And with just that one rewriting, that one edit of the right side of the equation, or proof I should say, what do you notice? We got the same thing. Okay? So instead of trying to combine the right side, instead of trying to combine this to look like the other side, I just rewrote. I decomposed the fraction from the left and ended up with the same two parts in terms of sine and cosine that I have over here. And that's the goal. Get the same thing on both sides, any way possible.